Okay. Hi guys, this is for A-Day students and for anyone that wants to go over the lecture again. This is going to be a quick lecture over different types of chemical reactions, and this is going to be the first lecture that we're going to go over in the new year. So this is going to be types of chemical reactions, and hopefully you guys watch it. Okay, so we're going to start. So the things that you guys need to be able to get out of this is be able to differentiate. So first, I want you guys to read what it says. So it says differentiate among double replacement reactions, which we will go over that some other time. And oxidation reduction reactions such as synthesis, decomposition, and single replacement and combustion reactions. So those are going to be the reactions that we're going to talk about. If I look up the word differentiate, it means recognize what makes something or someone different. So what you guys need to be able to do is, if I give you a formula, let's go to some chemical formulas. Let's look up chemical formulas. If I give you guys a chemical formula, well, these aren't very good examples. Chemical, let's look up types of chemical reactions. Not that. Okay, so this is just a little, these are pictures of the different types of chemical reactions. So what you guys are going to be able to do is, if we give you a type of a reaction, I want you guys to be able to tell me what are the different things about it. So for example, notice the difference between synthesis and decomposition. So in synthesis, they're using this cartoon to show that when you think about synthesis, you think about things being put together. And then decomposition, when we talk about decomposition in biology, is when something's being broken down. So in this little cartoon, we have these two people loving on each other. So that's gonna be our synthesis reaction. And then in decomposition, they broke up. So I need you guys to be able to figure out the difference between the different reactions. So what makes them different? What makes them, so if I give you a reaction, would you be able to tell me, is it decomposition? Is it combustion? What's going on? What's happening? Can you be able to tell the difference? And that's basically all you have to do. Okay, let's go back to the new one. So you guys, we're gonna go over 5 signs of a chemical reaction. Oxidation and reduction, we're just gonna go over a little bit over that. And then the types of different reactions, because all we have to do is be able to tell the difference, what makes them different. And then your objectives is identify 5 indicators of a chemical reaction, differentiate between the 4 different reactions, and then identify what species is reduced, oxidized, and what species is the reducing and oxidizing agent. So the third one is not really that important. The main thing that we want to focus on is be able to tell the difference between the different reactions. Okay, so let's go back to the chemical equations, because there's not that many examples on the PowerPoint, and I want you guys to be able to see the examples. Okay, so first thing that I want you guys to notice is that I want you guys to notice these little signs, the letters, the things that kind of, the symbols, basically, the symbols. So notice that this one has an S, this one has a G in parentheses, this one has an S. We have plus signs, we have arrow signs, and then all the other ones are a bit different too. We have this thing that says AQ, and I want you guys to notice the different symbols that each chemical equation has. So most of you guys do not know what the symbols are, and this is just a little chart that tells you the different symbols. So S is gonna equal solid, the state of it. O equals liquid. G is gonna be the gas state, and then AQ, which means aqueous, and it's misspelled here, but it means that it was dissolved in water. So this is just things that you guys can kind of see. Some of them are kind of known, or they're kind of like you would expect it, like H2O, it can be liquid, or O2, there's obviously going to be a gas. The little arrow in a chemical equation means that a reaction has to happen. So whenever you see a little arrow, it means that a reaction has happened. What else? A plus sign, it means that they're being added together, obviously, because plus signs means added together. And then the other ones we're not really going to see, but this little triangle we might see later on, it means that they added heat to it, or they added energy to it. Okay, that's just a little overview. So we went over this before. What are some signs that a chemical reaction has occurred? So I want you guys to come up with some signs that a chemical reaction has occurred. So when we did this a while ago, I had a piece of paper and I burned it with a lighter. And I wanted you guys to see what happens when I apply, when a chemical reaction occurs, because that is a chemical change. That is a chemical reaction. So what are some signs that a chemical reaction has occurred? People in the other class said there's a change in odor. So for example, sour milk. Sour milk smells so bad. So that's an example of a chemical reaction. Another one said a change in shape. So whenever we burn something, we have a solid and then it just turns into ash. Someone else said, well, I can't remember all the things that they said, so we're gonna go to the next slide. Temperature change, that's one that I forgot to say, temperature change. So if you guys, let me look up hot pockets. Not the pockets that you see during, like the hot pockets you put in your pocket. I forgot what they're called, but you basically break it and it heats up. So that's a temperature change that you can see. Light being produced. The best example of that is a glow stick. So a glow stick, light is being produced, and that's a chemical change. And then color change, obviously, if you burn something or you cook something, the color is going to change. And then formation of a precipitate, that just means that a solid was being formed. So if we mix two chemicals together and a solid is being formed, that's a chemical change. Production of gas, the Alka-Seltzer being put into the water, gas is being produced, that's a chemical change. So these are, I mean, that's a sign of a chemical change, but it's a sign of a chemical reaction. So these are the signs that we know that a chemical reaction has taken place. Okay, next slide. Why is it important to know the different types of reactions? So I asked the people in class, why is it important to know the different types of reactions? And these are the different types of reactions on here. I asked them, why do you think it's important to know the different types of reactions? And then I told them not to say that because it's on the test, like to actually give me a reason as to why they are important, or why is it good to know the different types of reactions. And these are some of the different types of reactions. All of these are good examples. And if you if I'm gonna give you a question and I give you just H2 and O2 and the synthesis reaction, I tell you it's a synthesis reaction. What do you think from the word synthesis that the products would be? So that was the main thing that I wanted to get, is that if you know the different types of reactions and you know what you are given, you can kind of predict what is going to come out. So that is a good way, that is one of the main reasons why the types of reactions is important, because if I give you something and I'm like, it is a decomposition reaction, and I give you this, and you know that decomposition is when something breaks down, you can kind of predict what is going to come out. You can kind of predict what are going to be the products. The products are the things that come out, and then these are going to be products, and then our reactants are going to be the things we get. So that's why types of chemical reactions is important to know, because you can kind of predict what might happen at the end. This is just vocab words that you guys should know. I'm pretty sure this will come up later on. So if I put a picture on the next slide. This is the different types of chemical, well, this is an example of oxidation and reduction. And what I want you guys to remember, because a lot of people are having issues with this, is that we know that electrons are negative. So just because we have this plus sign over here does not mean that we have more electrons. The plus signs means protons. So whenever you guys see this number, you guys think that that means they have two electrons, which is completely wrong. This means that it has more protons. So that's one of the things that you guys are kind of not understanding, which is fine because it's been a while. But if we have a plus sign, that means protons. So what it's the two vocab words that you guys need to know is this word called oxidation and this word called reduction. And oxidation and reduction is when you are either gaining electrons or losing electrons. So whichever one happens, you will either be oxidized or reduced. So that's why we need to know these vocab words. And this happens when electrons are being transferred from one place to another. So by transfer, we mean that they're being moved from one place to another. So these two words you guys need to know. And then you guys need to know, just in case you guys see the word redox. Redox is just if it has oxidation or reduction happening. So if you guys see that the electrons are being changed, you guys do need to know that. And then let's just go to the example. I put this picture just so you guys can visualize it. So oxidation is a loss of electrons. So if you notice, most of the time, if it doesn't have a charge like this one, it just means that the charge is zero. Because if you guys remember, all elements are neutral. So I'm going to put that all elements are neutral. I'm going to put that just in case you forgot. And by neutral, I mean that they are not negative or positive. So they're just there. So we have Mg0. And it's going to, when it goes to the product side, it is Mg2+. And notice that this became positive. Okay. So if it becomes more positive, Are we gaining or losing electrons? And that's the main thing that you guys were not understanding, is that whenever something becomes more positive, we're talking about charge-wise, this does not mean 2 plus electrons. It means 2 plus the charge. So we're losing electrons because you remember electrons are negative. They're negative. So if we're becoming more positive, we're losing electrons. On this one, the reduction side, it's going from copper 2 plus to copper, which if it doesn't have anything, it means that it's neutral, meaning it has a charge of 0. So if we're going from 2 plus to 0, and if you guys know the number line, you know, 2 plus 2, 1 plus 0, and after you go past that, you're going to have -1, -2. So this, if we're taking the positive away, then we're becoming more negative. So reduction is going to be the gain of electrons. And a good way to remember this is that if you're being reduced to nothing, then that means that you're in a bad place. That's one way to remember it. But just like the word being reduced, like you're taking stuff away from you. Another way to remember it is oil rig. So oxidation is gonna be O is gonna be oxidation. I is gonna be is. L is gonna be losing. R is gonna be reduction. I is gonna be is, and then G is gonna be gain. So oxidation is losing, reduction is gaining, and we're talking about electron. Okay, so I need you guys to know those words just in case, and you guys do need to know the oxidation numbers. So I'll put the oxidation numbers over here. So you guys do need to know this. We already went over it, so if you guys don't remember, you guys can either do it 2 ways. Most of the time, I just told you guys to, I told you guys to memorize it, but I feel like you guys know more about the valence electrons. So if you guys remember, the valence electrons is the group number, rather than just memorizing the numbers. And then we have 1 valence electrons, 2 valence electrons, 3, all the way to 8. So we got to start to 1 through 8. If you guys know, or if you guys remember, if we take this 1 valence electron, if we take it away, it will become more negative because we want to have 8, or we want to fill up our shell. This one has 2 valence electrons, so what will be easier, for me to take 2 away or for me to add 6 more? It will be easier for me to take 2 away, so it will become more negative. This one, wait, let me start over again. I messed up. If I take this 1 valence electron, it will be +1. If I take the 2 valence electrons, it will be +2. Notice I also got confused. And then this one, if it has 3, 4, 5 valence electrons, is it easier for me to add more electrons to it for me to have 8? Or is it easier for me to take the 5? It will be easier for me to add 3 more. If I add more electrons, I become more negative, so it will be -3. This one has 6, so I need to add 2 electrons. This one has 7, I need to add 1 electron. And then this one, I don't have to add anything to it. It's just gonna be 0. So, and just know that this side is gonna be positive, this side is going to be negative. Now, you guys do need to know these oxidation numbers. And then I asked you guys a couple questions on the Nearpod. So from C to +4, and it doesn't let me write the numbers on top. So I wrote this little thing, this little arrow to show that it's up. So C to +4, are we gaining or losing electrons? If we're becoming more positive, which positive equals the protons and negative equals electrons. Am I gaining or losing electrons? And the answer should have been losing electrons. The next one, let me go to the next one. O2 to O. And remember that if it doesn't have anything, it just means 0. If I'm going to -2 to 0, which this is more positive than this one, am I gaining or losing electrons? And the right answer should have been losing because we're becoming more positive. Next one, oxidation or reduction. This one's asking you to know the vocab words between oxidation and reduction. One way to remember it is oil rig. So oil, which means oxidation, is losing. And this one is reduction, is gaining. And this was the same question as the other one. We are losing electrons. So this is going to be oxidation because we're becoming more positive. So if we're becoming more positive, we're losing electrons. And then this one is F to F1. And notice we are going from 0 to -1. This is also asking you to know the difference between oxidation and reduction. One way to remember it is oil rig. And oil means oxidation is losing, reduction is gaining. And I know my handwriting is not very good. Gaining. So 0 to -1, we're becoming more negative. So if we're becoming more negative, we're gaining electrons. So that is why the answer is reduction. So I just wanted you guys to know the difference between those two vocab words, just in case it ever comes up. And then I'm going to give you guys the oxidation numbers, but I will tell you how you guys to look for the oxidation numbers. This one is a bit different. So anything that doesn't have a charge on it, unless it tells you it has a charge, like if this one was Fe2+, then the charge will be 2+. But because it doesn't have a charge, it's just 0. But on this one, on these compounds, remember compounds means 2 elements put together. If you guys remember how to figure out the charges, you guys have to look up the oxidation numbers. And if we go back to the periodic table, and if you know your oxidation numbers and know that this side is positive, this side is negative, it will be +1, +2, +3, plus or minus -4, -3, -2, -1, 0. And the first thing that I would do is I will go and find the charge of oxygen because that is set. So I'm going to go back, and I know that oxygen is -2 from the oxidation numbers. And there's another oxygen over here. And if you remember how we name transition metals, because remember, let's go back. This is iron, and this is aluminum, if you guys remember. So iron is right here. This is our iron. And where is aluminum? Aluminum's over here. This is aluminum. This is iron. So iron is not set, if you guys remember about transition metals, because this is a transition metal, and then aluminum is set. So, but if you guys remember how to write these formulas, you guys know that you have to find the oxidation numbers and you have to cross them. So if I know that this 2 is gonna go over here, then I'm pretty sure that the oxidation number for iron is gonna be +3. It's gonna be this one. So it should be Fe2, 3. And then this one will be the same thing because oxygen, we know it's -2. Al is going to be 3. We cross the numbers, and that is how we got this. So you guys need to know the oxidation numbers. But all I really want you guys to know is that if I was to give you this, so we know that oxygen is -2, Aluminum is +3. Iron is also +3. And this is 0. Notice that O2 is the same, so we can't really talk about them. But we can talk about the other ones. And notice that aluminum is going from 0 to +3. Is this oxidation or reduction? It's becoming more positive. So is it oxidation or reduction? And the answer would have been oxidation. Because remember, oxidation is losing. So it's losing electrons, it's becoming more positive. So that is what I would have gotten for that. And on this one, it's going F3 plus to Fe0. And this is going to be more negative. And if I know what it means to become more negative, I know that it is going to be reduction. So this is going to be reduction. But is this really what we want to know? Not really. And that's the same. What I really want you guys to know is I want you guys to know the different types of reactions. That is the main thing that we're trying to do. So the different types of reactions are these. There's one missing, but I do need you guys to know the different types of reactions. So in the other class, they found this picture to be very helpful. And I think you think it's very helpful to look at the pictures that they have here. There's a lot of pictures that you guys can see. But the main thing that you guys need to get out of this is the different types of reactions. You guys need to be able to differentiate, which is the main thing that we're trying to do, is figure out the different types of reactions. Okay, so the first reaction that we're going to go over is combustion reaction. So combustion reaction is anything that reacts with oxygen. So anything that reacts with oxygen is going to be a combustion reaction. So an example of a combustion reaction is going to be something that looks similar to this. So we have this reaction, it has oxygen in the middle, in the reactant side, and then most of the time, it ends up with CO2 and water. So that's an example of a combustion reaction. So whenever you see an oxygen in the reactant side, which is the things we start with, it's going to be a combustion reaction. Second one, decomposition. So when we're talking about decomposition, we're talking about anything that is broken down. So if you see this, you see the little bond between A and B, and then what happens is they are broken down. So if you know that from biology that like composition is when something is broken down, and you see an example of this water molecule being broken down into H2 and O2, then that is a decomposition reaction. Single replacement reaction. So when we think about replacement, we're talking about an element being completely being replaced. So there's a better picture of this over here where you can see it by colors. This is a good example. You have A and B put together and C by itself. What happens is that the B is being replaced with the C. So now we have A and C being bonded and then B by itself. So that's what's called single replacement. If we see the example in a chemical form, single replacement reactions, we have zinc, we have hydrochloric acid, and then what happens is that the zinc and the hydrogen are being replaced. So that's a good example of a single replacement. And then we have a bunch of other pictures. Next, we have synthesis reaction. So the example that they used here is sodium and chlorine, and then they have sodium chloride. That's a good example of a synthesis reaction. So when you see anything being added together, that is a synthesis reaction. So if we go to the examples that they have here, synthesis, you have A and B being separated, and then they have a bond together when they are going through the product side. And then the example that they used was this hydrogen and this oxygen, and then them being added together to make H2O. And then this is just a summary of everything that you guys everything that we've gone over. So you guys do need to know the different types of reactions, but you guys all you guys have to do is be able to differentiate. And by differentiate, I mean, what makes the reactions different? So if I was to give you a reaction like this, and you didn't know, and I didn't give you anything, I didn't give you the vocab words. Let's find a better example. Just this one, this mercury with oxygen, and you see that it's broken down. Which type of reaction would it be? Would it be synthesis, decomposition, single replacement, or combustion? And then if you know that in decomposition means breaking down, then the best answer that I would pick will be decomposition. If I see something that's being added together, they're bonded, they were separate but now they're together, then it will be synthesis. If I see something that's being replaced by another thing, then I will pick single displacement. If I see something that has, so this one, you would think it would be combustion reaction, but it's not combustion reaction, because remember, combustion reaction has oxygen in the front, but this is not a combustion reaction. Combustion reaction not only has to have an O2 in the front, but it also has to have CO2, a gas at the end. So that's why this synthesis reaction is not a combustion reaction. So your homework for today is, I want you guys to pick 3 questions that you guys want to do. Not too much. And I want you guys to, so this is gonna be your homework. This is your homework. And I want you guys to pick different reactions, 3 different reactions you guys want to do. So if you see whichever one you want to do, and then just tell me what type of reaction it is. But the first thing you have to do is balance it. So notice that these reactions are not balanced. These reactions are not balanced. You guys have to figure out the coefficients. If you guys don't remember how to balance a chemical reaction, go back in the notes or come to tutoring. But I just need you guys to do 3 different questions that you guys want to do. And that's about it. So hopefully you guys got something out of this. And then please turn in any assignments. And that's it for today. But thank you for watching, and shout out to Alexander and Julian once again. And that's it.